Kubernetes is very complex. There are multiple complicated things that are to be configured. There are unanticipated complexities and difficulties that a user might face during the deployment. So, some users or people in a team are likely to make mistakes that can lead to deployment failure. Check these top pod errors, which DevOps engineers have to deal with. First is CrashLoopBackOff error. This means a container in the pod is beginning, crashing, resuming, and crashing again. That is, the process in your container has failed. This could happen either due to a shortage of CPU or memory resources, or when many containers attempt to lock the same file. Second is out-of-memory error. Proper configuration of resource allocation is always advised for pods to work seamlessly. Poor resource allocation might result in entire cluster failure. A simple resource allocation issue can prevent the cluster's other running workloads from receiving the resources they need, as the newly deployed pod has consumed all of the available memory, leading to crash. Issue with liveness and readiness probes. Remember, just because your application container is running doesn't mean that it is working. Essentially, liveness or readiness probes will periodically perform an action to confirm that your application is working as intended. If liveness probe fails, Kubernetes will kill your container and create a new one. If readiness probe fails, that pod will not be available as a service endpoint, leading to errors. Looking at the logs from your pod is a good place to start debugging. Fourth is ImagePullBackOff error. ImagePullBackOff error is when Kubernetes isn't able to retrieve the image from the container. This could be because the image name provided in the pod spec is invalid, or the tag specified in the image doesn't exist, or the specified image in the private registry and Kubernetes cluster doesn't have access to that. Fifth is CreateContainerConfig Error. This error occurs when a Kubernetes tries to create a container in a pod, but fails before the container enters running state. This error can be identified by running kublet git pods command. This error usually occurs when ConfigMap is missing or secret is missing. Sixth is persistent volume fails to mount. Trying to create a deployment that references persistent volume that don't exist is another common error. Whether you are using persistent volume claim or directly accessing a persistent disk, the result is very similar. To resolve the issue, you might need to create a persistent volume, and once the disk is created, the controller manager will mount the disk and kickstart the container creation process. Lastly, missing ConfigMap or secret. Common mistakes developers make is create deployments that reference properties of config maps or secrets that don't exist. Kubernetes best practices recommend passing application runtime configuration through config maps or secrets. This data could include database credentials, API endpoint, or other configuration flags. Managed Kubernetes is available on E2E Cloud. Click the link in the description to request a free trial.